Okay, good afternoon, everybody. Welcome to the second webinar of the THERMOS the training program. Welcome to all our beloved trainers, and I hope you still have some energy left today to enjoy our second webinar that's gonna focus on embedding thermos in our city. So the agenda for today, as you can see here, will be a brief welcome and introduction by Daniela Torres from ICLEI. She will explain a bit of how to embed thermos in a city and how to create a district heating network. Then we have Juan Baro from Creara, who will explain us how to develop a case study with thermos, what are the most important aspects we need for creating a case study, and he will give us also an overview of all the case studies created by the Thermos project with the tool, of course. Then we would like you to see some practical case studies as examples. This will be one case study from Jelgava presented by Valdis from Fortum, and another case study from the city of Warsaw presented by Wojciech from KAPE. We hope these case studies are inspiring for you and that they encourage you to develop a case study with thermos. And then at the end, we will have some questions and answers and next steps to be taking with the training program. So like this, I will like to give the floor already to my colleague Daniela Torres to make you the introduction to the webinar. Hello, Daniela.
Hello, Julian. Thank you very much for the introduction. I just well, today is a very interesting day because we are going to speak about the importance of thermos as part of the city. Sometimes we might be thinking, but why a tool that is used by consultants, is used by utilities, is changing the paradigm of energy and district heating on a city level. So what I want to tell you that with thermos, we think, and that's why we as ICLEI, as part of the are part of the thermos project, and also that's why part of the partners of the project are cities, is because we really think that thermos is a tool that will accelerate the energy transition in cities and of course drive city sustainability. We think that with the use of thermos in different cities worldwide, we will achieve several things. One of it, of course, the reduction of greenhouse gas emissions. Of course, we are going to improve the air quality of our cities. We hope also to get energy efficiency improvements of the whole energy system of the city, and especially towards reducing energy costs on a local level. Of course, thermos will allow us to identify and facilitate the integration of local and renewable energy sources in the city energy system. Of course, we think that also thermos is going to accelerate the development of new projects of energy, of district energy networks in a city level, creating jobs, creating investments, and of course, improving city sustainability as a whole. If we go to the next slide, I wanted to tell you that when we started designing thermos, we conceived thermos as a tool to be used especially by local governments. But during the process of developing the tool and engaging with trainers, with ambassadors, and all the family that we are now the thermos projects, we have identified that cities are one of the main beneficiaries of the using thermos, but also a whole community of utilities, consultants, research, and academic partners are also key users for thermos. If we go to the next slide, we can see that the main challenges that cities are facing now to advance on district energy developments rely especially under two situations: whether the cities have existing district energy networks or they don't have existing energy network as a whole. Thermos give us the opportunity to evaluate district energy networks on any city in any part of the world. And of course, we find different cities having different challenges. Like, for example, some cities do not know or are not familiar with district energy networks or district heating and cooling. Also, other cities face challenges that there's a lack of data and lack of data on the energy demand that cities cannot have access to. And also, if the cities wants to develop some planning activities and district energy planning activities, some cities face that sometimes there's a high level of expertise required that sometimes they don't have. And also, doing a planning of new or existing district heating network, of course, brings up from cost for cities that sometimes they don't have. So we think that THERMOS is going to help cities to overcome these challenges. And now, no more theory, and let's go directly to practice. So thank you very much. And now, Julian, I think we have to give the floor to Juan. Thank you very much on my side.
Thank you very much, Daniela, for the introduction. So as you said, now I would like to give the floor to Juan Valero from CREARA. He's going to explain us a bit how to create a case study with THERMOS and give us an overview of some case studies already created in the project. So hello, Juan, the floor is yours.
All right, let me share my screen. I know you're already viewing my screen. Yeah. I guess, yeah. All right, so thank you very much for the introduction, guys. My name is Juan Valero. I'm from CREARA, and I'm here to talk to you about the information needed to develop a case study. This has proven to be one of the most challenging parts of the case study development process, as most of the users don't know what information can they implement into the tool, how to implement it, or where to get it from. So without further ado, I'll start. First, we've divided the needed data to develop a case study into three main categories. For the first section, the energetic one, we have the demand parameters. These would cover from the annual demands, peak base radio, and this allows us to calculate the demand for each of the buildings. Then we have information regarding the location status relative to district heating and cooling systems. Here we would cover like existing district heating and cooling characteristics, the insulation of the buildings in the area, that kind of information. And then we have the initial network characteristics, which will cover flow temperatures, required demand, etc. Then we go to the economic section, which will allow us to develop the financial model associated with the case study. So here we have the costs related to civil works needed to develop the project, either pipe work or pumping, mechanical costs, the costs associated with the construction of the heat supply will go here. And then we'll have the definition of the energy market with the tariffs, benchmarks, and emissions costs. Then we go to the technical data. This data first helps us give a little bit more information regarding our case study. First of all is the geographical data. These would be the locations of the project, the size and the dimensions of the buildings. These, as we are using GIS files, will already be embedded into the files, so there's no need to input it. So then we have the supply specific generated emissions, as well as the emissions limit, which will help us develop the emissions model, and the alternative systems characteristics. If we want to consider individual systems as an alternative to our district heating, we could always input their characteristics such as costs or, I don't know, to get a more accurate model. This information could be implemented through two different steps. First is the definition of the case study with a new map into your new project, and then the fine-tuning of the model parameters. which is performed on the tool interface. The definition or new map. The tool allows the user to input information through the two different ways. First, using directly OpenStreetMaps, in which case you won't have the option to assign certain parameters as a bulk method, because you have to do it individually in each of the buildings of the imported area. In the case we use our own data and we have the GIS files, we have divided the information into three categories again: demand, dimensioning, and characteristics. All these information you'll find in the drop-down menu of the implementation. And here what you can find are different parameters that would adjust depending on the kind of model that you want to develop. Meaning, if you want a 2D method, you would only need the floor area, no building height, nothing. If you want to have a 3D building method, you will need a LiDAR, maybe building height or floor area. And then if you want a more accurate model, you can use the annual heat or cooling demands, which are more accurate. Then the characteristics will help us down the road to change or adjust our model in the fine-tuning section. It's interesting to perform this task this way, because doing it individually could be a little painstaking. So if you have the option to develop your own data, you'll need a separate column in each of the attribute tables to correspond one of these parameters, and then it be associated from the beginning. Then we have the fine tuning, which is performed in the tool interface. And here we can see we have divided into 5 categories which match your left side menu, which are objective, tariffs, pipes, insulation, and individual systems. I'll go through this pretty fast, but this is developed because the tool is thought to be used for different locations. So in order to adjust the parameters to the different locations, you need to input your tariffs, your pipe costs, which vary a lot as we have seen when developing the tool. So here we've tried to give you as many options as we could. You'll find that sometimes information might be redundant, as you'll be able to, for example, with the tariffs, you'll be able to input from unit charge to capacity charge to multiple things that you might not need for your tariff, but we've tried to give you as many options as possible, so you can basically trim it to your needs. Actually, here this part is really different between each other, and it'd be more useful to look it up on the tool. Anyhow, it's pretty straightforward, and you could always resource to the hub, which is also in that menu. Regarding the different use cases that could be designed using the tool, we have 4 of them. First one would be the expansion of our existing network. Second one would be the planning of a network given a known heating source. This case is pretty much used for existing, for plants that have an existing energy source that wants to be used. Then we have the planning of a new network serving a given local thermal demand using one or more energy sources, and then identifying optimized solutions when considering energy efficient measures, thermal networks, and individual heating and cooling measures. So fourth one would be for taking into account emissions or other other measures that we want to project in our model. THERMOS project partners have covered 8 different cities. Some of the cities have performed more than one analysis. As of right now, we have Granollers in Spain, which has performed 3 of them with different scenarios. Ecocongos, for example, was one of the biggest challenges with as it was an industrial district heating and it needed steam. So that was a really interesting case study. Then they did another 2 in order to test other scenarios. Cascais has been a replication city, and they also perform scenario 2. As you can see, most of the cities have performed new networks. That's because district heating is not as common as we think, and most of them are trying to develop new networks or even the first network in the city. As a curiosity, Granollers and Warsaw, well, I think Wojciech will speak to that later, but they both took into account the emissions, and that's why we have considered that in scenario 4, as they were developing a new network, but either way they were considering additional measures. So that's how it's that's the current status of the project. We also have a couple external partners that are also interested in developing new cases, but none has done yet. If you want any additional information, here you have the links to most of our resources, and you can find them always in the THERMOS project website. So that's it for me. Thank you very much.
Thank you very much, Juan, for this interesting presentation. I think you made clear how to start with that. Oh, you're not hearing me? Do you hear me?
Yes.
Okay. Yep. So thank you, Juan. I agree that these case studies are very interesting, so please go ahead and check them in the website, of course. And now I would like that one of our speakers shows you directly one of these case studies developed, and so that you can see a further perspective on it. So we are going to start with Valdis, with the city of Jelgava, where they develop one of these case studies there with THERMOS. Yeah, Valdis. So I'm going to give you the floor.
Yes.
Yeah, sorry, Daniela.
Yeah, no, 1 minute. I will make Valdis presenter, but we have one question at Juan. So
Okay.
if I can share it. So Juan, one of our participants asks that they have some difficulty to model the physical buildings and to draw the physical buildings within THERMOS. And also she asks where she can find or he can find the GIS data. If it's not available, what are the sources to find the GIS data? Can you give some insight about that?
Okay, thank you. That's one of the main issues that we found. When you draw the buildings in the tool directly, it could be tedious, and also it sometimes has errors as it's not the main goal of the tool. We have felt that it's easier to use the GIS files and upload them themselves. Well, Wojciech, which is coming here, has had a really good experience with that, and well, for the design of the buildings, like it's just, I guess, manual. Sometimes cities make available GIS files with all the buildings in the city, but usually these files are like have really big sizes and are not really useful. So if you are considering a small development, sometimes it's better just to develop it yourself. And also, most of the times when it's a new development, you have the AutoCAD files, DX for the WG. So those files could be converted into GIS, even though it's not really precise, but it could be done, and it takes a lot of work.
Perfect. Thank you, Juan.
Okay, thank you very much for your answer, Juan. So now, yes, I give the floor to Valdis so that he can present us the case study developed with the THERMOS tool in Jelgava in Latvia. So, hello, Valdis, welcome.
Hello. So you see my screen now?
Yep, we see it.
Yes, I can start. Maybe I'm from utility of Jelgava city. We are district heating operator and producer also of energy. And I just want to comment on this previous question about these GIS files. We also had these problems to find this data. And when we got from municipality, the quality of GIS file was not in so good quality to use in tool. So we used this OpenStreetMaps tools, and we got this slider layer data. So it's, and with that solution, it's quite good, gives quite good estimates of demand. And here,
Valdis,
so about,
Valdis,
yeah.
This is Daniela. Just one more question we have in the chat now, and I don't want to leave it to the end, but can also GIS files can be obtained from Google Maps, or that is not so easy?
I guess not. Maybe there's some more specialist.
Actually,
Okay.
in the THERMOS tool, if you are not uploading GIS data to create your model, you can select the OpenStreets data that is like Google Maps for creating your model based on those pre-made maps. So that's like the standard option, actually.
Okay, perfect. Thank you for
But the
clarifying.
problem is it's two-dimensional. So if you want like three-dimensional, you have to add the slider layer on top of that map.
Yeah.
Exactly. Thank you. But there are alternatives that our trainers can use. And anyway, if the trainers, when developing their case, you have some trouble on the GIS files, please write us, and we can help you sort this problem if possible. So now, thank you very much, Valdis. Go ahead, please.
So I will just shortly introduce why we find THERMOS tool helping us to better face our challenges. So this is our main plant of district heating, where it's produced for the city. It's biomass, most modern in our country, biomass CHP plant, which services about 16,000 households and some almost 200 business customers. And the network is quite big for Latvia's measures. It's 75 kilometers. And yes, that is our main business here. So we are like selling heat and related services, hot water, substations, service of substations heat in multi-partner houses. And also we, as a byproduct, are selling electricity to grid, and also do all the metering and invoicing work for the city, because we are in not typical situations that we are invoicing almost each single flat is our customer. It's not typical situation in our country. And when we want to be more efficient, we're doing some technical improvements. Just last year, at the end of last year, we made this heat storage. It's already one season and it worked very well, better as expected. Then we are now start very active work on change of fuel. We are using as a main fuel biomass, wood chips, but now we are planning to add RDF fuel in some percentage, and we are now starting all these procedures, official procedures to go in that direction. And the third part is this network efficiency and density. To increase, we need to make it more dense. We need more customers, because one thing that the capacities of existing production units are enough to service more customers, and you available funding, many multi-partner houses are doing insulation energy efficiency works, which reduces a little this demand part, and we have to compensate it somehow. And there is some challenges to develop the network in fast pace, and as it's regulated business, so we don't have a lot of excess resources, so we are just very team is as big as it's needed for main services, and it's hard to allocate resources for development. And if you want to make some kind of network layouts and think where we could grow, so far it was very complicated process. We don't have any special software, and if you would like to have some specially developed softwares which are existing in market, they are very expensive, they are very complicated. If you have to fully train some person to use it, and if it doesn't use it regularly, as the city is not so big, so it's not worth to buy such softwares. And if there is some case, we focus on that, but we don't have this zoom out view on our city, especially for some areas where private houses are mostly located. And at the moment, if we would like to make some network drawing, some engineer would take QGIS software, spend a couple of days or weeks when he have free time to make some drawings and calculations. So it's very time consuming, was before THERMOS. Yes, and the challenge we have is to make decision which are the city parts where we make next steps. Like here, you can see our existing district heating network in red color. And yes, the question is which direction should we go, because most big customers we have connected to our network, and there is a lot of areas which are quite near to our district heating network, but it's unclear if that, mostly it's private house areas, it's unclear if the capacities and demands are enough to do this expansion, and if yes, where to start. And the THERMOS tool is helpful tool because as it in this nice text says, it rapidly and cheaply helps to plan expansion of existing systems. For that reasons we use this tool. And the beauty of THERMOS is that it's very simple, so even not engineers can use it. And yes, so what data used, what we data inputs used, as I at the beginning told, we used OpenStreetMaps and LiDAR. This didn't work for us as the quality of file wasn't enough good to understand by the tool, but this LiDAR layer on top of OpenStreetMaps give quite good quite good results at the end for demands. Piping costs, it's a more complicated question a little because it very depends on specific places, and the tool for us it seemed a little complicated to put these inputs to work correctly, but after playing for a while we managed this also. Tariff is very simple, and we didn't focus so much on production costs and emissions, because for our planning the main part was that we needed to have some kind of demand estimates of area and investment estimates of that area. That was the main outputs we wanted to get from these calculations. And yes, the outputs what we have helps us to understand what are the optimal layout option, what is optimal layout of network of area we selected. So we at the moment we use it for private house areas, and just a couple of recently last months I would say management asked to focus more on that issues, so we can take like one area and then we can use simply the tool to zoom in some, I don't know, one small street part, analyze some 5-6 buildings, investment part for that pipe, what is the total demand, total income, and total investments, and then we can make report for management within 5-20 minutes with all the demand estimates, pipe size, pipe costs, and that is a lot of times faster than it was previously, when we would ask engineers to make those drawings and calculations, and it would maybe take some week or more even. Yes, so we can very fastly make these estimations of demands and investments, and especially we use this for private house areas, and the demand estimates looks very precise, and it's totally enough to make at least first level decisions should we make on which direction make next steps. Yes, so I would encourage also others to use this tool, as we find it very usable and comfortable. Thank you.
Thank you very much, Valdis, for this interesting case study. I agree with you. We encourage everyone to use Thermos to create their own cases. And I think it was really interesting to see how, thanks to Thermos, you could test all these different networks to see where was the best location for that, and the tool actually could save like not just hours but days of work thanks to using the Thermos, right? So I think that's the main aim of the tool, that we can solve these complicated problems very easily. Exactly. Yeah.
And one more thing, it's one is time saving, and other that I don't have to ask engineers. I can do these basic calculations without this technical specialist.
Yeah, exactly. So it's very easy to use, and really anyone like taking this course you are making now can perfectly use it. Okay, so thank you very much. Are there any questions for Valdis now? Daniela, did you see that? Does
Yes, we have a question.
Does the tool support?
Yes.
Yeah. So does the tool support use of loops in the distribution network? If so, does it factor the impact of loops in the cost estimation of the distribution network? With loops, they mean meshed systems. Do you have an answer for that, Valdis, maybe?
Yeah, it's quite a technical question. If you mean loops, I don't know, because we use it just for some end sides of network, so just to expand it, so we don't look in that level. I cannot comment. Maybe some developer can. That's quite the technical question.
Yeah, I don't know if Juan or Wojciech can.
Yeah, from what we have seen, loops can be included into the network, no problem. It just we had some problems in the beginning with pipe diameters, because it usually designs for a certain flow, but considering the pipe diameter, it just considers that pipe to be meshed. Yeah.
Okay. Thank you. Anyways, if you have more technical questions or questions regarding more to the training itself, you can ask them at the end also in the question and answer section. And we also have an expert from CSE that might help us also answering this kind of questions today. So now I would like to give the floor to Wojciech from KAPE in order him to share his case study from Warsaw. So please, Wojciech.
Oh yeah, sorry, I was muted. Sharing the screen, I'm not sure. Can you confirm? Can you see the presentation?
Yeah, we are seeing the screen a bit small, maybe.
Yeah, we are seeing your presenter view, Wojciech. We can see the next slide.
Yeah.
Okay, probably because I have two monitors.
Two monitors, yeah. But it's fine.
Yeah, only if you can put it full screen somehow, if not. It's fine.
Yeah, I'll try again.
Yeah, no, it's okay.
Yeah. Okay. My name is Wojciech Stańczyk. I work for KAPE, the Polish National Energy Conservation Agency. And I worked together with the city of Warsaw to create the case study for Warsaw using THERMOS. Unfortunately, Marta Kęsik, who's working with me on this case study, was not available today, but I hope I will do a good job presenting it to you today. To start with, I want to tell you more about the district heating network in Warsaw. It is over 1,700 kilometers long, so it's one of the biggest district heating networks in Europe, and that's why it's a bit challenging to analyze, especially from the city point of view, who doesn't have a lot of data on the network. So there's a lot of challenges that is very difficult to analyze for the city with such a big network, and I think THERMOS helps that a lot. The network as well covers almost 80% of the district heating needs of the inhabitants in Warsaw. So it's a very big heating network, and 91% of the heat is produced with cogeneration. It's mostly from the Żerań and Siekierki sites, and only the 10% is only on the severe weather conditions, like a harsh winter, when it is used not in a cogeneration process. And a bit different look on the city, a bit less detailed, but to give you a bigger overview, and also for you to see the sources sizes. It's over 4.5 gigawatts of heat power installed, so very big sources, a huge network, so it gives a bit challenging for us to analyze, but we try to work on it with THERMOS. And apart from the size, another challenges that we are facing is that the district heating network is private. So it's a different company than the city itself. So it is hard for the city to obtain data on it and to analyze it. So the tools actually helps that a lot, because you can easily input data into the tool to analyze it. Another challenge is that planning for the mitigation of mitigation actions in the city, it is hard to identify, because the district heating network is a key way of providing heat in the city. So it needs to be analyzed in the SECAP. So THERMOS can help that and to do that. And the last thing is that there's always a question between if network is the best solution or other systems, local systems, or even individual systems should be installed, and how it affects the emissions and other costs and etc. So this also helps. THERMOS also helps to do that. So what we decided to do is just to choose one part of the city, not the whole city, and to analyze it as a, let's say, first case that we can replicate in other places as well, to do the test. And we chose the Białowęka district. We thought it would be a good example, because there's new development in this area. So we can see whether this new development should use the district heating solutions or other solution to decrease the emissions and the costs. And also there is quite a few buildings near the district heating network that don't really use it. So we could check whether it's a cost issue, or why do people tend to use their own heating source instead of district heating, and if it would be more feasible to use the district heating network, so this solution would be more efficient for them, and maybe we could propose it to those buildings. To show you on the map, it's just the top part. It's not the circle is a bit bigger than the actual. I think it's much bigger than the actual localization, but just to show you, it's just the small tip at the end of the network that we used to analyze. And yeah, as was mentioned on the first presentation, there are 4 basic steps that for basic use cases that you can use with Thermos. And for us, the most important thing was the first one and the 4th one. So adding new sites and connections to the existing network, because yeah, we're working with a huge network and we wanted to see if we can develop it further, especially because there was an oversized pipe at that location. So it was meant to develop in a way so we could check where is the best place to use that heat that the pipe can provide. And also the 4th way, so comparing or assessing the performance of specific network and non-network solutions. We focused on that quite a lot. We wanted to compare whether the district heating is the best way to provide the heat to the buildings and compare it with the individual sources, especially because we use currently mostly non-renewable sources in the district heating network. So the 90% is provided through cogeneration, but the cogeneration is based on coal mostly. So it comes with a CO2 impact. So sometimes it may be, for now, better to use individual solutions if they are also with a lower CO2 emissions. The network itself is changing and is planned to change, but the city itself has less impact on that, and it's more on the decision making from the owners of the plants. So here is a close-up on our case. We separated the previously mentioned area into 2 focus areas. The A area is more with the new development kind of network. So we knew that there will be, or there are currently ongoing processes of constructing new buildings. So there will be new demand, and we wanted to know how it impacts the decision making in terms of development of the network. And the area B is the area very close to the pipeline. You can see the pipeline going through there, but many buildings around that pipeline are not connected, even though the pipeline is quite big. So it could potentially supply the energy to the nearby buildings, but for some reason those buildings were not connected yet. So we wanted to see if it's feasible for them, and how feasible is it. So this is how you can see it in Thermos. Yeah, this is those red buildings are already connected. So as you can see, only some of them are connected, and there's quite a lot of buildings that are yet to be connected, and that's what we were examining in this area. So what input do we need in the tool? Was the map plus specific building data, technical information about networks and sources, and financial information about networks and sources to be able to compare it. And I will talk more on each type of data to give you an overview what we did and why we did it. So first is the maps. We decided to choose a few different sources just to compare how the data sets and how the maps influence the final results. So we use the OpenStreetMap, which is very simple in the tool because you just click this option and it downloads itself. It doesn't really need much work with that. And we also use the GIS files. I think on the question of the GIS files, I think it's quite different between countries as well. So some GIS files in Poland you can easily obtain, but some may be harder. Maybe in some countries it's a bit different, but in principle you should be able to ask for it. The municipality and most of them have it, especially for such a big city as Warsaw. There was not that big of a problem to obtain this GIS file data, and we also wanted to play with a GIS file type of data. So we used the very basic information, like just the geometry of buildings for one estimation, and for the second one, we used the direct estimations of heat demand based on the benchmarks that we prepared earlier. So we have a overview of how the model models the demand, and how we model with our benchmarks and more traditional way the demand, like we would do through the GIS type of analysis. And for the new buildings, the GIS type of file is also very easy to use, because you can draw the buildings in GIS and then input the data. OpenStreetMap, then you have to add another layer to it, or add it in the THERMOS tool, which of course can be done as well. So it seemed to be a quite small area, but it actually covers about 800 buildings. 500 of them are residential. And in terms of demand and power estimation, it was around 65 gigawatt hours per year. This difference is because we used different data sets, so we could compare in each data set how close were the estimations. So it was very close, 1 gigawatt hour per year difference in both cases. The value in brackets is for the map without the new buildings. So we also had the estimations for the new buildings. There's quite a big development there. So without those developments, it would be more or less 49 gigawatt hours per year currently used through the network. Yeah, in terms of other inputs to the tool, the cost information, maybe you can see example and use this experience with yourself. There is an official tariff, so we used that to just to input it to the tool, and it was quite easy for us to do. For other cost information, it was a bit more challenging. For the pipe cost, we used our own experience, but it's this kind of data, as was also mentioned before, can be very tricky, because it's different, even city to city within one country, even like road to road, it can be quite different. So you usually would need to start the process to actually know the prices that the market can offer. So yeah, but you can use some kind of estimations at the very beginning to at least make the costs viable and to check it. So for the individual sources, because we also wanted to compare the district heating solution with the individual sources, so this was a very important part of us. We did a big study on that, so we used the values from that study. In terms of network, so we used some information from Warsaw, from the general statistics, to assign the correct costs and estimates. And this is how the solution looked at the very end. I don't want to talk more about why the results were such, not other, but just to give you a view of what we estimated and how can it look at the very end. So the blue ones are the buildings that were connected, and the other buildings are, so the green ones were those that use the individual solutions. So as you can see, it seems very reasonable. So the highly dense, the bigger buildings were connected, and those smaller buildings further from the network were not connected, which seemed very reasonable for us. So we thought the tool calculated it quite well. So for how can THERMOS help you? For us, it was very important because it helps the city to actually get involved in the planning process and use the data and the visualization to work on their SecApps and to finally achieve the ambitious goals for the city, and to be able to discuss this with the network owners and city planners, how to approach this solution, this difficult problem, this big city, this big network, and how to analyze it in the SecApp. And that's it from my side. If you have any questions, I will gladly answer them.
Okay, thank you very much, Wojciech, for presenting your case. I think it's very useful to see how useful indeed the THERMOS tool can be for, in this case, expanding an existing district heating network to a specific area already projected. So like to see how would be the best solution to a concrete case. And we actually have a question here. So Andre Muller was asking, is the benchmark data result available to be better prepared, in which cases a detailed energy demand calculation would be necessary? So do you have an answer for that?
For benchmarks, it was our own study. I think you should find some results, but I'm not sure if they're available in English, because it was a study on Poland. So I think they are available in Polish, but I'm not sure. But just for you to know, there's quite a lot of similar studies on EU level, or on your country level. Probably there are also some studies on individual benchmarks, so you can use it. It also, depending on what kind of benchmarks are you talking about, is it in terms of costs, or is it in terms of heat consumption per building? Because if it's heat consumption per building, I think it's almost always better to use the national benchmarks, because of the climate impact, so, and the building types and so on. So for that, of course, you should use the national benchmarks or your own benchmarks if you have. And for costs, it can be different. I think, for example, the boiler industry in Poland was quite big, because we use quite a lot of coal boilers for individual heating. So, for example, the cost may be a bit different than in other countries, but in general, this could be quite similar. And I think you can find national or EU studies on that as well.
Okay, thank you very much, Wojciech. So I think there are no more questions for the moment. So now I would like to tell you that we have already seen all the presentations that we would like to show you today. Now, well, I guess there are no more questions. I would like to tell you that today you have met 3 of our tutors for the case study. So if you finally decide to develop a case study with THERMOS, you could have as tutors the people from Creara here, from KAPE or from Fortum. So Valdis, Wojciech, and Juan, together with Paolo here, could be your tutors in the coming days for developing a case study. So we really encourage you to take the chance to develop a case study with them. And now I would like Daniela to share a little slide now, so that you get an overview of what's left for the training. So Daniela, can you share it? We are not hearing you, Daniela.
Yes, sorry,
Okay.
Julian, can you see my screen now?
No.
And there?
No. Now we see it. Okay,
now
thank you.
Okay, so just before going to the end, I would like to remind the journey that the Train the Trainers program has. We have to forget that we want to make it as easy as possible for you. So just a short overview. So far, we have done the webinar number 1 a couple of weeks ago. Today, we have done the webinar of embedding thermos in your city. I think that some of you have already explored the different challenges and the different exercises that are already there for you to develop. You know that you have the other option of doing, one option is you developing the thermal practical exercise, or you have the other option that is doing a case study. Hopefully after the session today, you've been motivated to do a case study. But also I would like to encourage you and make you remember that also there's a lot of material in our Thermos webpage with a lot of recorded webinars that you can access, you can enter, you can enjoy. I hope most of you have already seen some of them. I hope yes. If not, it will be a little more difficult for you to do the case study. I encourage you to do this. And yes, and just to let you know that we are half of the journey to finalize this Thermos Train the Trainers Pathway D. So hopefully we will be able to finalize in almost 29 days from now. So we are in the last push. So with that, just remember that we have to go ahead with our journey to become a super Thermos Train the Trainer person. Okay, that's all on my side, Julen.
Thank you very much, Daniela. I think it's super clear now, thanks to your smiley faces. And so now, if there are no more questions, I would like to.
Your presenter, yeah. No? Yeah.
Yeah. Are you seeing this?
Yes.
Okay. So as Daniela said, yes, the next steps now are to finish your exercises for the ones that are choosing this option. So we are glad to tell you that the third exercise and the explanation video for that exercise is now available, just as the rest of the exercises that you started now. And you can find it in the webpage. Also, please decide if you are making a case study by tomorrow, Friday. So just if you found it attractive today, please just write us an email saying, I would like to make a case study. We will assign you a tutor and you will have time to develop it until 1st December. Together with the exercises, please finish the 3 of them by the 1st of December. And finally, please join our very last webinar on 10th December, where we will ask some of the trainers, so some of you, to share your case studies with the audience, so that all of us can receive the outcomes of this training and see the work that you have done. So that said, thank you very much to all the attendees. Thank you, Daniela. Thank you, Juan, Wojciech, and Valdis, of course, for your presentations. I hope you have a lot of energy for finishing this training, and see you back on the 10th December. And of course, let us know if you have any questions during the process. Thank you.
Thank you very much. Bye-bye. We will answer some of the questions also via email. Bye-bye. Thank you.
Okay. Thank you.
Bye.
Bye-bye. Thank you.
Bye-bye. Thank you, Valdis.
Thank you.
Okay. Now we are going to close. Good job, Julen. We are